Hello and welcome back to another multivariable calculus video. Today we're going to be going over the hyperboloid of two sheets. This is the fifth video in our quadric surface unit. We are going to go ahead and explain what a quadric surface is again. Quadric surface is essentially a graph of a quadratics in three variables, x, y, and z. And our strategy for graphing these quadric surfaces is plotting intercepts, plotting traces, and completing the picture from there. We have gone over four shapes prior to this: the ellipsoid, the elliptic paraboloid, elliptic cones, and a hyperboloid of one sheet. Today we're going to be going over the hyperboloid of two sheets, like I said again. Let's go ahead and see what the general equation for this is. General equation is negative x squared over a squared minus y squared over b squared plus z squared over c squared is equal to 1. As we can see here, we have two negatives. Spoiled that in the last video, what two sheets versus one sheet is. Has two negatives. Two sheets, two negatives, one sheet, one negative. Without further ado, I think we can go ahead and get into an example. Let's graph negative x squared over 4 or minus y squared over 9 plus z squared over 16 is equal to 1. Go ahead and repeat our strategy. Got to grill it in our heads when doing quadric surfaces. We want to plot our intercepts. We want to plot our traces. And then we want to complete. As you can see, if you watch the last video, then you can see that I, in fact, made my x-axis steeper this time. So maybe my hyperboloid of two sheets will look better than my other drawings have been. We'll see, though. All right, step one. Let's get into it. Color coding again. Never mind, we're not going to color code. You'll see why. X-intercept. Maybe you can already see why. We don't know. Y and our z equal to 0. We have negative x squared over 4 is equal to 1. Negative x squared over 4 is equal to 1. Multiply both sides by 4. Uh-oh. Negative x squared is equal to 4. No solution there. Let's go to our y-intercept. Spoiler alert, it's going to be the exact same thing. X squared over 4 equal to 0. Z squared over 16 equal to 0. We have negative y squared over 9 is equal to 1. I'm just going to go ahead and skip a step real quick. Negative y squared is equal to 9. No solution either. Wow. Oh, I actually don't have room for my z-intercept this time. Our z-intercept, see, does this one even work? X 0, y 0, z squared over 16 is equal to 1. Looks like this might work. We have z squared over 16 is equal to 1. Multiply both sides out by 16. We have z squared is equal to 16. Square root both sides. We have z is equal to positive or negative 4. We only have z-intercepts, so let's go ahead and go over to our photo and graph that. I don't even need to do that, to be honest. 1, 2, 3, 4. I'm going to make it a little bit shorter. You guys are going to see why. This is going to be our z-intercepts. Negative, or 4, positive 4, and then negative 4 we'll put right here. Once again, you guys will see why when graphing the hyperboloid of two sheets. Intercepts done. Now we're going to want to plot our traces. We'll do down here. This one we're definitely going to want to color code. We'll go ahead and switch the order up today. I think I usually do green for my XZ trace. Apologize if I am inaccurate with that. XZ trace, meaning our y is set to 0. We have negative x squared over 4 plus z squared over 16 is equal to 1. Looks good. That is going to be our XZ trace. Yellow is my YZ, I think. I'm just going to like the opposite order of what I usually do. Meaning our x is equal to 0. Negative y squared over 9 plus z squared over 16 is equal to 1. Looks pretty doable. Negative y squared over 9 plus z squared over 25 is, oh shit, is it 25? It's 16. I'm used to 25. Whoopsies. Is equal to 1. There we go. That is going to be our YZ trace. Let's go ahead and do our XZ. I know I do this one in pink all the time. Spoiler alert, this is usually, or XY, sorry. Spoiler alert, this is the one that's usually the Z equals Z naught traces in these scenarios. We'll see. Alrighty. So, XY trace, that is going to be when our Z is set to 0. We have negative X squared over 4 minus Y squared over 9 is equal to 1. Negative X squared over 4 minus Y squared over 9 is equal to 1. Oh, I don't like that personally. Let's just go ahead and do a Z equals Z naught trace. Why? Well, there's no positives in there, first of all. I'm not very comfortable with that. So let's just go ahead and do a Z equals Z naught trace. So we have negative X squared over 4 minus Y squared over 9 plus, we have this over here, oops, never erased that, plus Z naught squared over 16 is equal to 1. Squared over 16 is equal to 1. So now we have negative X squared over 4 minus Y squared over 9 is equal to, subtract that negative Z naught out, 1 minus Z naught squared over 16. Okay, we have a slight problem here. So, how do I explain this? Well, let's go ahead and just multiply this by negative 1 first. Make it prettier. X squared over 4 plus Y squared over 9 is equal to, let's switch the order, Z naught squared over 16 minus 1. Okay. We have our quadratics on the left side, right? That means what? The minimum that these can be is 0, right? So if we went ahead and set Z naught squared over 16 minus 1 equals 0, that would, I'll just show the proof. Here, I'm not going to talk it out. And I'll do this one in a different color because this is just like a note. So, our x squared and y squared has to be over 4, x squared over 4 plus y squared over 9 has to be greater than 0 or equal to 0. Meaning, we have to make sure our z naught squared over 16 minus 1 is equal to 0 at the bare minimum, okay? Let's go ahead and solve this out. Z naught squared is equal to 1 over, 16. Z naught squared is equal to 16. Z naught is equal to positive or negative 4. The minimum that these need to be is positive or negative 4. So what I'm trying to say here is if our Z naught is 4, then there's a solution. But if it's let me make a little thing here. It's gonna be negative 4 has to be less than or equal to Z naught has to be less than or equal to 4. If, for example, we have anything in between this inequality, such as 0. Let's go ahead and use 0 as an example. If Z naught was set to 0, that means our x squared over 4 plus y squared over 9 is equal to negative 1. That cannot happen because, as we stated above, x squared over 4 plus y squared over 9 must be greater than or equal to 0. Meaning, this inequality right here makes it so that our z naught cannot be anything in between this right here. So, essentially what I'm trying to say is our z naught, absolute value, must be greater than 4. If it is less than 4, no solution. If our z naught is greater than 4, we're good. Greater or equal to 4. Then we're good. Because we see, if we plot 4, then we have 4 squared over 16. That's 16 over 16. 1 minus 1 equals 0. We cannot have anything in between negative 4 and 4 as our z naught value. So we are going to have, as you can see here, we've graphed our z equals z naught trace enough that we know that these are just going to be ellipses, okay? If our z naught once again, I need to reiterate this so that we can understand why the hyperboloid of 2 sheets looks how it does. I'm going to come over to the graph here. For our z equals z naught trace, -4 and 4, this whole area down here is no-go. Because if we do, then we have no solution. So this is no-go land. This is why our z-intercept was -4 and +4. Okay, this area right there is just not. It's not going to work. There's no solution. Therefore, it is undefined. Okay. So, just keeping that in mind, we are actually. I'm going to go ahead and just to make sure that we know that this area down here is not graphable. It's undefined. Because like we said, we just got to think about it. X squared over 4 plus y squared over 9 has to be greater than or equal to 0. Therefore, our z naught squared over 16 must be greater than 4. The absolute value of our z naught must be greater than or equal to 4. So we have all of our traces. Let's go ahead and graph it. Our xz trace. XZ trace is going to be, I'm never good at this one. It's going to be another hyperbola. We are going to go ahead and do, a little bit too. I don't like that. I'm going to make it a little bit more. Ooh, that's pretty. Okay. Okay. Well, maybe not. Okay, it's my pictures are always ugly. We know this by now. YZ trace another hyperbola in the YZ plane. We're gonna have boop, boop. Oh yeah. Oh yeah. Looks good. Z equals Z naught trace. That is going to be the ellipse x squared over 4 plus y squared over 9 is equal to Z naught squared over 16 minus 1. So we are just gonna have hyperbolas, or not hyperbolas, ellipses. Oh yeah, do one more at the very top here. Okay, well, this is positive and negative, right? So we are going to have the exact same things down here. Whoop. Oh, god dang it. Okay, boop, boop. Is it ugly? Again, guys, I am no artist, unfortunately. That's why I do so much math. That's why I'm an engineering undergraduate. No good at math. Or no good at... I'm not really good at math either, but whatever. Anyway, I digress. That is basically what our hyperboloid of 2 sheets looks like. Once again, once we understand exactly what our limits are and why that red area right there is a no-go, and why it is undefined there, then it's pretty clear why it looks the way it does. That is our hyperboloid of 2 sheets. I'm going to erase this just for that. There we go. Now it looks a lot cleaner. Some of my best work yet, if I might say so myself. That is our hyperboloid of 2 sheets. In the next video, we will be looking at our 6th and last quadric surface. And I'm going to warn you, that one's really going to be ugly because this one's hard to graph. I'll warn you right now. That is our final surface for hyperboloid 2 sheets. That's our final picture. Thank you very much.